Hi, I'm Michelle.
Okay, the AEV project for 1182 students teaches us about project documentation, teamwork, and the design process.
The project involves designing the Advanced Energy Vehicle and putting it through a series of tests. Each student must create a design for the AEV, then the designs are compared in order to come up with the most acceptable model. This design is chosen mostly through the process of concept screening and concept scoring. Once the group's design is printed and built and the code is written, the AEV is tested. The AEV must be able to traverse the track above the classroom and transport cargo from one point to another. This must be done in the most efficient way possible. Therefore, the utmost care is placed in mass, cost, energy efficiency, and more.
Oh, hey, didn't see you there. We were just talking about how we can make our AEV very efficient.
Hi, my name is Dylan Greer. I'm going to go through a little bit of the design process we did for the AEV project. So to begin, we kind of had a brainstorming and design for each student. So we had 4 individual designs, and we decided to choose Joe's design for our final. And from there we made a prototype of Joe's design, and we did concept scoring and concept screening with his design compared to other designs that were given to us, and a few designs that we created ourselves. And then after the screening and scoring, we took our design and made 2 prototypes. One prototype we decided not to use and discontinue, and the other one that we decided to use was a T-shaped model. It was like that with the wheels up here. And really the model was very light and coasted for a long time. And it only had one propeller, and with this design there was a flaw that it wasn't able to pull the R2-D2. So we had to introduce a new design which was based off of this second prototype. We put another motor that was on top of the design near the wheels when the other motor was down here. This allowed for an easier pull of the R2-D2, which was our final design.
Hey, I'm Mike Reese. When it came time for our final testing, one thing we really wanted to focus on was energy efficiency. So instead of using sensor calls and the go-to absolute position sensor call in the Arduino programming, we decided to use go-for commands for distance, so that when it came time for the AEV to stop, it really just coasted, and this allowed it to stop under its own friction and momentum instead of starting up the propellers again in the reverse direction and slowing them, because that would have required more power, and more power means that more energy is going to be used at the end of the run. So for this reason, we think that our design was able to be a little bit more energy efficient, and that showed in our the graph of energy efficiency versus time, and it allowed us to create an AEV that above all was energy efficient. Another big issue was the issue of the battery, because we noticed that within 0.02 of a voltage there was a difference in the AEV running. So we had a voltmeter, and we measured each battery before each run, and we decided that 8.37 volts plus or minus 1/100th of a volt was what we were going to use for final testing. So we ended up using 8.37 volts, and this allowed our code to be consistent for a battery at 8.37 plus or minus 0.01 volts, and that was really important for our final run. At the end of the day, the AEV taught us a lot about time management and teamwork. Project documentation was really, you needed to stay on top of it because there were a lot of progress reports, and also there were a lot of obstacles to overcome, and overcoming those was part of the project. You know, each obstacle that we met, we had to find a solution to, you know, with the battery, with energy efficiency, with transporting the cargo. Each of those required some work to help fix it and to make it the best it could possibly be for the final project.